Welcome everyone. For today's prep, we're going to be looking at the idea of how to find the slope of a curve. So we've been dealing with equations of lines so far and how to find the slope of a line. Well, now we're going to kind of try to generalize this to more general type geometric objects like curves. And this is going to be, really a geometric question. And this is going to lead us to our first major calculus idea. And this question of finding the slope of a curve, we're going to see has many different applications. So, I have a list of some of the applications we're going to be looking at throughout the course. But we're going to start with the idea of tangent lines. So, tangent lines really come around when we're talking about circles. And so there's ways to construct, if you have a circle and you have a point that you're interested in that sits on the circle itself, there's ways to construct the tangent line at that point. And a few important properties that tangent line has is that the tangent line just barely touches the circle at this one point. So it just touches the circle at that one point. And if you zoom in on that point of tangency, like we have right here, the tangent line and the circle right around that point look very similar. So it almost looks like they're going in the same direction right at that one point. And then the circle curves away. But at that one point, the tangent line and the circle look very similar. So this gives us a way to define the slope of the circle at this point P. So the slope of our circle at this point is just going to be the same thing as the slope of that tangent line. So we have, in this case, we have this curve, and we're defining the slope at a particular point to be the slope of the tangent line at that point. And this kind of gives us our definition. So we're going to define the slope of a general curve, not just a circle, to be the slope of the tangent line to the curve at the point that we're interested in. So as an example, let's look at this general curve. In this case, it's a parabola, so it's not a circle. And we have this point that we're interested in. So we'll call this our point of tangency. We'll call it point P. And the idea is we have our curve, and then at this point, we're going to draw in the tangent line. And again, if we kind of zoom in on that point of tangency, what are some properties that we want our tangent line to have? Well, if we zoom in nice and close to that point, kind of like what we've seen here, we want it to kind of have the same properties as it does for when we talk about tangent lines and circles. So near point P, the tangent line really should only touch the curve once. It's kind of the ideal there. And then near point P, the tangent line and the curve should look very similar. So if we're zooming in on this point of tangency, notice that we have our tangent line, and then you can kind of see the parabola there. But for the most part, right around this point, it looks like both the curve and the tangent line, they're kind of going in the same direction. They look very similar. They overlap. They look like they're going to the same place. And if you go back to the bigger picture, yeah, our tangent line, right around this point of tangency, the line and the curve look very similar. And then if you keep going, then you can see the curve kind of, does its thing, and the tangent line they kind of go in opposite directions here. But right around that point of tangency, the line and the curve look very similar. So the question is, once we have our tangent line drawn, how can we figure out its slope? And we're going to try a couple examples here. So let's look at this parabola one a little bit more closely. So the function in this case is x squared, and we have the graph below, and we want to find the slope of the graph at point P with coordinates 1, 1, and then we're going to do it again for point Q with coordinates -2, 4. All right, so first of all, when we're trying to find the slope of the graph, we need to use the slope of the tangent line. So let's start with point P. we're going to do our slope calculation. All right, so the idea is first you identify the point of tangency on your curve. So we want to find the slope of our graph at point P. So we first find where point P is on our graph, and then we draw the tangent line there. So in this case, the tangent line is already drawn for us. So this is the tangent line at point P. So each point on the curve is going to have its own tangent line. So this is our tangent line at point P. And once we've identified our point, and then once we've drawn in the tangent line there so that it has those nice properties, then we just have to figure out the slope of this line. And so one way to do this is we have one point that sits on our line, and we want to identify a second point that sits on this tangent line. So you want to look, kind of scan through the entire line, and look for where it intersects grid lines. So in this case, if we keep going, find an easy to read point right there. So this point doesn't sit on our actual curve, it sits on this tangent line. So let's call this one, P2. So the second point we're going to use, related to point P here. All right, so what are the coordinates for this other point? Well, the x-coordinate, it looks to be about 2. Yeah, we're kind of estimating here. And the y-coordinate looks to be about 3. So I would say this has coordinates 2, 3. And our original point of tangency has coordinates 1, 1. So once we've found our point of tangency, we've drawn in our tangent line, and we've picked out a second point that sits on the tangent line, now we just have 2 points, a line, and we can use our regular slope formula. So if you remember, our regular slope formula says the slope is the change in y over the change in x. So delta y over delta x. It's our regular slope formula there. And, well, now let's look at the change in y. So the y-coordinate from one of the points minus the y-coordinate from the other point. So we end up with 3 minus 1. So that's going to be our change in y. And then the x-coordinate from the point minus the x-coordinate from the other point. So the change in x is going to be 2 minus 1. And we end up with 2 over 1, or just 2. So this is the slope of our curve at point P. So this is the slope of our tangent line, and it's the slope of our curve as well at this point. So this really the slope of our tangent line, but the way we're defining our slope of our curve, it matches up with the slope of our tangent line. All right, so let's try this again. Now we're going to do it for point Q. And for point Q here, we have to do a little bit more work because the point Q is not already plotted for us, and we have to draw in the tangent line for ourselves. All right, so let's look for point Q. So the coordinates are -2, 4, and just -2 is right here. So we're going to plot our point, which is way up here. And then we want to kind of draw the tangent line there. And when we draw the tangent line, it kind of helps to start by drawing in a little section of the tangent line. So zoom in, get really close, draw a little section of the tangent line, and then zoom back out and just kind of extend. So let's try that. So we're going to zoom in on our point Q. So this is point Q. And we're going to just kind of draw a little tangent line right at that point, just a little line segment. Because if you zoom in on any of these points, kind of gets a little blurry, but if you zoom in on any of those points, you can draw a little line segment. And then the idea is we're going to zoom out and then just connect and then just make that line segment, just extend it in all directions. So let's actually do it at point Q here. So we zoom in and we draw a little line segment, and I want it to overlap. So that would look something good. That would look pretty good. Now, what would not be a good little line segment to draw? Well, something like this. Because there's kind of a clear difference between this tangent line and our little section of the curve here. So we want our little tangent line that we draw to kind of overlap the actual curve. And so then we zoom out, and this kind of gives us a line to work with. So then we just extend that little line segment that we drew in both directions. All right. So this is our tangent line at point Q. All right. So now we want to figure out the slope of this line. So again, slope of a line is just change in y over change in x. And so we already know one point that sits on this line. So we're kind of given one free point here, Q, with coordinates -2, 4. And we just want to scan through then the line that we drew and look for another easy to read point. And so in this case, I would say, probably right around here. That would be another easy to read point. So I'll call that one Q2. And that looks to be coordinates -1, 0. All right, so now we have 2 points that sit on this second tangent line that we drew. So now you just use the regular slope formula. So we do the difference, do the change in y. So in this case, the y coordinate from the first point is 4, and then the y coordinate from the second point is 0. And then we do the change in x. So we go from -2 to -1. So we're going from -2 minus -1. And if we do that subtraction, we end up with 4 over -1, which is -4. And as a way to kind of check our slope calculation here, you can see that as we go from point Q down to point Q2 here, we're going down 4 units in the y direction for every 1 unit in the x direction that we move to the right. So the slope here is negative, and we can kind of see that with our downward tangent line here. All right, so this is the process for estimating the slope of a curve by drawing in the tangent line. So if we have a point that we're interested in that sits on our curve, we start by, first finding the point. Then we want to draw a little tangent line at that point to the curve. So the way to do that is start by drawing a little line segment, and then once you have the line segment that kind of overlaps the curve, extend it out in both directions. And then this gives you a line, and you have one point already. You just want to find a second point that sits on that line and use our regular slope formula. All right, so we're going to try another example of this in class. So we'll see you then. Bye-bye.